Welcome to my channel. Now we are discussing the database advanced databases topic. Here first topic is introduction. First we discuss the introduction. In introduction we discuss about the database applications. First subscribe to my channel to see the latest MTech subject and BTech subjects lessons. So now here first, what is database management system? So database management system, it is a collection of interrelated data and a set of programs to access this data. Nothing but DBMS is a collection of interrelated data and a set of programs data and programs. To access those data, we can use the database management system. So collection of data system, collection of data is usually referred as a database. In the database we have a collection of data contains information relevant to the enterprise. The primary goal of the DBMS is to provide a way to store and retrieve database information that is both convenient and efficient. We can retrieve the data on the database by conveniently and efficiently. So database systems are designed to manage large bodies of information. Management of data involves both defining structures for storing information and providing the mechanism and for manipulating of information also. In addition to database system, we must ensure the safety of information stored despite of the system crashes or attempts unauthorized access. We can secure the information from the crashes and the unauthorized access also in the DBMS. So in most organizations, computer scientists have developed large body of concepts and techniques for managing the data. So now we discuss about the database system applications in what areas we can use the database. So here the some representative applications are there. Banking applications. In banking applications we can use these databases for customer information, accounts and loans and banking transactions. We can use this database. And then airlines. In airlines we can use for reservation of scheduling information. And airline among the first to use the database in geographically distributed manner. So in airlines also we can use the database for reservation tickets and scheduling the ticket. And airlines were among the first to be used in database geographically. Next, in universities we can use these databases for student information, course registration, grades, all these things. And next is credit card transactions. For credit card transaction also we can use this database. For purpose of credit card and generation of monthly statements, you can use the database applications. So next in telecommunications, you can use these databases for keeping records of calls made and generally monthly bills, maintaining the balances, prepaid calling cards, and storing information about the communication networks. We can use this in telecommunications. We can use these databases. And next, in finance we can use for storing the information about the holding sales and purchase of the financial instruments such as stock, bonds, purchasing bonds, stocks, and storing the real-time market data. Enable online trading. For all these things we can use database. All this stored in the database. Next, sales for customer product purchase information in sales like e-commerce websites, Amazon, Flipkart, we can use this database. And online trade online retailers for sales of data. Note about the plus online order tracking. This is also online retailers like Amazon, Flipkart, order tracking, generation, recommendation list, maintaining the online product evaluations. You can use this database. Next is in manufacturing process for management of supply chain for tracking producing the items of factories, inventories of the items, warehouse and stores, order of items. You can use this database in manufacturing plants. And then in human resources nothing but in companies, information about the employees salaries, payroll, taxes, benefits, generation of paychecks. For this one also we can use these databases. So in different areas we can use these databases. Next is what is the purpose of database systems. Here exact purpose in database systems, what we can do. So database systems allows response to early methods of computerized management of commercial data. The example of such methods are part of the bank enterprise. Among the data, information about the customer savings account. In banking sector we can use this data. Main purpose, one way to give information to computer, storing operating system files, store in the operating system files. So database can be stored in the operating system files. It allows the users to manipulate the information. So users can be manipulate the information, users can change the information by using the database. And the system is a number of application programs that manipulate the files, including the programs. So here debit or credit in the account. In the account we can debit the money or credit the money. That for that programs we can use the database. And add a new account, you can add the new account and find the balance of the account, generate monthly statements. All these tasks are used in the DBMS. So here the programmers write the application programs to meet these needs of the bank. For these needs we can write the application programs. So new application programs are added to the system when the need arises. Okay, next one is file processing. In file processing system support the conventional operating system. It remains stores permanent records of various files. In file processing system we can store the records of the files. Need the different applications exact records from them. So next, what are the different disadvantages we can use for this one. In file processing system has a number of disadvantages. Disadvantages are data redundancy and inconsistency. Redundancy is nothing but multiple data can be occurred. Some different programmers create the files application programs over the long period. Various files likely to be have different structures written in several programming languages. Moreover, some information can be duplicated in several places. Information can be duplicated in several places. For example, address and telephone number can be for the customer can be appear in the file consist of the savings account records. The file consists of checking account records. So name and address can be appeared in the different places. So redundancy can be occurred here, and redundancy leads to the high storage and access cost. So save information can be stored in the multiple places. So high storage will be occurred. In addition to it causes the data inconsistency. Various copies of some data may be no longer agree here. For example, changing the customer address may be reflected to saving account records, but not else in the somewhere. If you change the address, can be stored change in the one place only, not all places. These are the advantages: inconsistency and redundancy. Next is difficulty in accessing the data. Difficulty in accessing the data. Suppose one of the bank officers need to find out the names of the customers who live within the particular postal code. The other asks the data processing department generate such list, because the designers of the original system do not despite the request. There is no application program on hand to meet it. So however, the application program is generate the list of all customers. The bank officers now with two choices: either obtain the list of all customers and exact need information, ask the system programmers to write the necessary application program. Both alternatives are objectively unsatisfactory. Suppose the program is written in several ways that some officer need to trim. So these are different problems can be occurred. For accessing the one up customer, we can use these different processes there. This is also one problem. Next is data isolation. Because data scattered in various files may be in different formats. Writing a new application program to retrieve the appropriate data is difficult. So data isolation, this is also one problem. Data scattered in various files. Data can be stored in the various files, maybe different formats. Data also different formats. For new application programs, retrieve the appropriate data. Retrieving the data also difficult. Next is integrity problems. Data values stored in the database must satisfy the certain types consistency constraints. For example, balance of certain types of data bank accounts never fall before the prescribed amount. Developers enforce these constraints the system by adding the appropriate code of various applications. However, the new constraints are added, it's difficult to change the programs. It's nothing but once we write the program, if the time to time the constraints are changed, the new constraints are occurred, we have to change again the programs. So for this one problem will occur integrated problems. If you want to change the program, the problem can be compound for constraints involving the several data and the different lines. So next is atomicity problem. So computer the mechanism of electrical device subject to failure. The electrical device is failure in many applications. It's a crucial task. Failure will be occurred. Data can be stored consistent to be consistent state and then existed prior to the failure. So consider the program is to transfer the $50 from the account to A account to B. If the failure is occurred during the execution of program, it is possible to that $50 can be removed from the account but not credited to the account B. These errors will be occurred, resulting in the inconsistent database. So clearly essential that database consistency is efficient both in credit and debit occurred. Fund transfer must be atomic. So for this one, fund transfer can be atomic. This feature is compulsory. Atomic atomic problems can be occurred in the case of failures, power failures, all these things. Next problem is concurrent access anomaly. Concurrent access and security problems. These are different problems are there. Which is concurrent, nothing but performance is faster and responses. Performance is slow. Next is view of data. In view of data, we can discuss about the data abstraction. Data abstraction is physical level, logical level. Need of efficiency of the designers is to complex data structures present in data in database. There are two different levels of abstractions are there. Physical level abstraction and the abstraction nothing but it must reserve data efficiently reserving. Physical level and logical level, we can discuss what is physical level. The low level of abstraction describe the how data can be actually stored. We can describe how the data can be stored in physical low level. The physical level describe the complex of low level data structure. In physical level we will discuss the complex of low level data structure. So logical level here. Next higher level of abstraction describes the what data can be stored in the database. So in the logical level, what is the data can be stored in the database and what relationships exist among the data. In low level data, in physical level describe the low level data structure. Logical level we discuss about the what data can be stored in the database, relationship among them. Here we see the picture. View level, view 1, view 2, view n. The top one is the view level, in middle one is the logical level, first one is the physical level. In logical level we can write the program logical, physical level we can write the main topics, view level is the output program. So view level, highest level of abstraction, describe the part of the entire database. Here describe the part of entire database. Through the logical level use the simple structure. Yes, even though logical level use simple structure completely, it remains because the variety of information can be stored in the large database. Many of the users in the database do not need this information, need to across the only part of the database. View level of abstraction exists to simplify their interaction with them, provides many of the views in some databases. So view describe the view of database. So concepts of data types and programming language clarify the distinction among levels of abstraction. Many high-level programmings support the structured type. For example, Pascal like database records. Pascal records are like this: type customer record, customer ID, customer name, customer street. All the here can be stored in the strings. Pascal structure here. Next, code defines a new data type customer. 4 fields. These are 4 fields. Each field has a name type associated. Banking data interface may have the several record types here. Account and employee. Account and employee. So in physical level, so for according to this example, we can discuss the physical, logical, and level. In physical level, customer account employee record can be described as a block of the consecutive storage locations. In physical level, we can use the customer account and the employee. These are the main fields. These records can be described as a block in physical level and storage locations. For example, in locations we can use the words bytes. Compiler hides the level of details of the programmer. Highest low level of storage details for the database programmers. So in logical level, each such record can be described as a type definition. In logical level, we can use the type definition. Interrelationship among the record types. Programming use the programming languages, high level abstractions. In the view level, we can use the computer users use a set of application programs. In view level, we can use the application programs that hides details of data types and hide the data type details. And in view level, several views of database is defined. Database users view view addition to hiding the details of the logical level of the database. To view the provide a security mechanism, users accessing the certain parts of database, all these things. Next is like views are 3 levels: physical, logical, and view levels are database data abstraction levels. Next, instances and schemas. So here, what is instance? Collection of information stored in the database in a particular moment is called as an instance. Collection of information stored in the database in a particular moment is called instance. Next, what is schema? The overall design of the database is called as database schema. Database design is called as a schema. Schema can be changed into infrequently at all. So here schemas are physical schema describe the database design at the physical level. Logical schema describe the database design at the logical level. Also several schemas in the view level also. These sometimes called as subschemas. Application programs are said to be the physical data independence if they does not depend on the physical schema. If the data does not depend on the physical schema, is called as physical data independence. Next to data models, we can discuss the data models. Data models is important topic here. Data model underlying the structure of database. Underlying the structure of database is called as a data model. Collection of conceptual tools describing the data relations, data semantics, consistency, constants. Collection of conceptual tools for describing the data is data relations, data semantics, and consistency. These are different tools of the conceptual tools. Data model provides the way to describe the design of database at the physical, logical, and low level. Database called as a way to describe the database at the physical level, logical level, low level. Describe data at three levels. So there are a number of different data models will be covered in the text. Data models can be classified into 4 categories: So data models are classified into four categories: relational model, ER model, object based model, and semi structured data model. So first, relational model. Relational model uses these data models and DML. These are the we could discuss in the next class. Databases, data languages, DML, all these things. Subscribe to my channel to see the DBMS lessons.